what we're going to do maybe in the future. And as you can see, this was produced by ChatGPT. So I used some of these new tools. I was quite excited for the discussion afterwards, because the discussions are both great innovators in this space, and there's some other innovators also in the audience. So I'm really hoping for an interesting discussion. Now, I just put up my standard disclosure slides. I will talk certainly about some unapproved use of technology, some ideas, because every time you start, just when you start typing in what could be the future tools and devices, you just go down the rabbit hole, because there's so many things, and then you leave that talk for a week and open it again, and there's like 3 or 4 new things, and it's like, I can't talk about everything, because this just would, burst the time I would have available. So I picked a few things of maybe things that might never come, because people thought it's a stupid idea, tried it, didn't work, and then moved on to the next thing. But I thought I will highlight a few areas where we might move. Some maybe a bit sooner than later, and others maybe in 20, 30 years or 50 years or never. We will never know, because that field is moving extremely quickly. But before I start, what's the next generation? I thought, let's quickly have a look backwards, what we were doing 100 years ago, 200 years ago. Well, if you just go back 250, 275 years, if we needed resuscitation, it was quite rudimentary what they were thinking they would like to do. One of the things was, hey, maybe we should just rub some parts of the body with different foods and see if that will stimulate the breathing. Not sure if it worked or well, because there's no reports how well it might have worked, but certainly these were ideas they were thinking about. If you jump forward roughly 100 years or 75 years, you will hear the first description of resuscitation attached to the cord, because Blondel said, hey, if you start giving mouth to mouth to a baby who is not breathing, you can see suddenly that the cord is starting to pulsate, and if you stop, the cord will stop again. So it was an idea, but then we never followed up on that to continue to do this work. Now we're working on this and hoping that this will become one of the next steps in our resuscitation, but it's not something which is not around for a long period of time. And then over the last 100 years, or at least up to maybe the early 1900s, we tried many other things. We tried nebulizing brandy mist. Maybe that was good for the pediatrician or the obstetrician. Not sure how it did to the baby. Pinching, so stimulating in a certain way, but maybe a bit more aggressive. Electric shocks, not sure if that works, but on electric shock topics, what is one of the problems we have with mask ventilation is that the glottis is closed. And we heard about that way, and there is in ENT areas where they can stimulate the glottis with electric stimulation from outside. So maybe someone will come up with an idea that you can stimulate the glottis and the glottis opens, and you don't have to worry about this in the future. So who knows if someone is thinking about it, but that's certainly available for adults already. So maybe it's just someone needs to miniaturize it to a newborn size. And certainly they tried many things rectally. I don't know what the success rate was of any of these, but certainly these was available for the clinicians to try corn, raven beaks, or just smoke. The Germans did go a different way. They thought, if I stimulate the baby by just slamming it upwards and downwards, not sure how many of them had IVH at the end, but certainly this was not something which stayed on to be done. And on the other hand, I really would like to know how many of these babies would slip out of their hands when they were tried doing this. But this was certainly also something which was postulated, and you can see it was done by Schultz in 1871. Some of the things people have said in the past is something we tried to do or still working on it, like try to keep the babies warm, rate the lung. It's very important. Don't give too much oxygen. And we heard a lot about oxygen today, because particularly in germ babies, it could be toxic. So that's nothing new. At some point we went astray and did the opposite, but this is certainly something people were trying to do many years ago. But we came a long way. Like from, if I look at this, what they were doing in Germany, compared to having a baby in a plastic bag, maybe a flow sensor on, using a T-piece. So we've got a long way. And if you look at any of the movies where they talk about the future, and this is from Back to the Future 2, a lot of things they predict or use in their movies have come to our daily lives nowadays. And things they had in the Back to the Future 2 were like smartphones, smartwatches, smart glasses. They're maybe not around yet as much, but they're up and coming. Smart homes. We don't have flying cars yet, but we have helicopters. So there's certainly a lot of these things have come to fruition in our daily life. So certainly there will be a lot of tools also available in the future, which might be proposed now or over the next years, or have been proposed in the last 10 years, and we will see them in our delivery rooms. So whenever you look, it's the future's now. AI is here. AI will help us with moving it forward. It will be much more functional, individualized, because we really want to treat that one patient, maybe not down to the DNA level, but we certainly want to have a lot of models available where we can predict what that patient might need, and I will show you a few examples soon. But AI as part of this new generation tool is only one tool. So we'll shortly talk about AI, and we have one great discussant later up who is an AI expert as well. So we can have a nice chat about AI. But AI is only part of it's just part of it. So there's AI, machine learning, and deep learning, which is all interconnected and part of it. And you can see here this very interesting loop where we need to find out where AI belongs, in which way it belongs, how we are kept in the loop, how ethics is going to be involved, how the parents are involved, where has the data access, how we can interpret this, and so on. So that's certainly something we want to look into. There will be a lot of things in the future. And you can see here that, yes, AI is often the headline it's used, but there's many different areas. Could be machine learning, where we use a lot of signals from our vital signs, maybe even an infant crying noise or other things to predict certain outcomes and figure out, that's maybe something we need to look at. And then on the other hand is deep learning, where we could use MRI images, thermogram images, head ultrasound, retinal scans for predicting ROP or diagnosing ROP. So there's many of these options. And Sullivan et al., it's a couple of years ago, so there's many others out there since then, but they really nicely summarized all the potential applications at that time. And a lot of them applications are focused on prediction, or, okay, this is how I can identify a disease. So we certainly, I would say, more in the infancy of AI, because there's many more steps, because we don't just want to predict that an IVH is happening. It doesn't help me at the bedside when AI tells me, there's a 90% of a probability that there will be an IVH. I would like to know what I can do to prevent it. That would be the next and more important step. And there's many things, and I'm sort of going to pick a few things, like which is more and more upcoming, like automatic seizure detection, where you use your alpha EEG, for example, and while it runs on a therapeutic hypothermia baby, AI can detect in the background, hey, there's a seizure, and you might want to treat it or not. So, which might be invisible to us when we assess the baby, or to the bedside nurses. It certainly might be interesting to see how it works with surfactant dosing, or predicting if that baby can remain extubated, or so prevent extubation failure, so that we have to reintubate. But a lot of these things are only as good as what the data we feed in. So that's certainly also something we always have to take into account. Now, Is it used in resuscitation? Well, there's a few things out there, and this work by Ryan's group et al. Is, for example, using deep learning to identify where the glottis is. Now, can that help us in the future? Yeah, maybe this is a program which is integrated in your video laryngoscope so that you don't have to start looking for it. It just highlights, here's where the tube needs to go, yeah? And maybe it can help you guide your endotracheal tube if you need to intubate into your glottis more accurately and faster, for example. So that is maybe something. On the other hand, there is a group out of Norway with Siren Rettendal who uses heat cameras to map time of birth and then the interventions which are ongoing. The advantage of heat cameras is that you cannot identify any person, you cannot identify the mom, you cannot identify the baby. So often there's concerns when we try to do video recording is that, hey, we can't use video recordings because we identify everyone, and that way you get nicely around so you would never know who was there or wasn't present. So that might be something which can help you as well. I just add that from one of Ryan's papers because I think this is something we might want to discuss in more detail, how we're going to integrate AI ethically into our routine, because at least in Canada, there's a lot of push, that parents, for example, are part owner of the data. There's an ownership of people, there's an ownership of indigenous communities of the data. So we can't just jump forward and say, we will do all this because they have a say in how the data is used. So that's certainly something where we might have to do some more in-depth discussion. But AI is not the only thing. And there's many other things. There might be drones, there might be 3D printing, there might be environmental stimulus, which are slightly different. So I thought I'm going to highlight a few areas which is starting to be used or might come in the future. So how does the delivery room of the future might look, where maybe the mom sits in the middle, the baby somewhere, and there's many other tools available. So bear with me, I will guide you through what might happen or might never happen. Well, let's start with mom. So what can happen or can change with the mother or the birthing person during pregnancy? Well, I think one thing where there's a lot of work going on, if you start looking into, is how can we improve fetal heart rate monitoring? Because fetal heart rate monitoring isn't really great. It's, as you all know, is device you put on the abdomen and measure fetal heart rate. Sometimes it works, sometimes it doesn't work. Sometimes you get the heartbeat from the mom and the obstetrician reassures you, it was the baby's heart rate. But just like that baby was stillborn already. So it's certainly a lot of things you can improve with that area. Now, what's out there? Well, there's several companies out there who are starting to produce little patches which record heart rate, oxygen saturation, respiratory rate, temperature. So they record a lot of different values on the abdomen to figure out what's the baby's doing. And you can see the agreement could be better, but it's a good start, I would say. Here with this one, it gets up to 95, so plus or minus 8 beats per minute in the fetal heart rate with a fetal heart rate patch, where it basically does an ECG onto an app. So maybe this is something which can help. This, and on the next page I have another one. These patches recognize fetal movements, and this is comes out of a Wii Nintendo console, which is not available anymore, but they used it. And when they compared that to what a birthing person feels, is like birthing persons feel often only 1 in 7 fetal movements. Now, an ultrasound, which you can't hold on all the time, can get up to 1 in 3. And the Wii was able to actually, this little device they have in there, which measures your accelerations, can measure 1 in 2 fetal movements. Now, just imagine when that could be integrated in a certain way in a patch, then all moms could have that at home, and once the fetal movements decrease for whatever reason, the app can alert them, saying, hey, there's something wrong, and they might go to see the obstetrician or go to the hospital. So maybe this is something in the next years when those patches get developed further, that we might see a reduction in any of these cases where there is a reduction in fetal movements or potential stillbirths because the moms get alerted relatively early. In Scandinavia, they have something what they call sensory delivery room, which seems like an interesting concept. This is a delivery room I'm pretty sure everybody has seen. This is how they look in our hospital. This is how they look in many hospitals. The sensory delivery room they propose and are used in Denmark, for example. Philips, as a company, has designing them. It's using like walls where you can put up whatever motif you would like. Doesn't matter what you think you would like. You can just change it. You also get an app with it, and the app is quite interesting because in the end the app tells you how to breathe, gives you these flowers, and this just tells you how often you have contractions, and the bigger the flower, the bigger the contraction is. So that actually will guide you through your pregnancy. Now, does that work? Well, no one has done a randomized trial, but there's observational data on it. So in the end, when they compared it with roughly 800 women, observational, retrospective, but they found that they were able to reduce one C-section for every 6 to 10 mothers in their study to when they used this sensory delivery room. So maybe, in the future we go into a more sensory-friendly environment for the mom, because a lot of had positive birth experience as well as had a reduction in their pain perception. So that's certainly maybe something which might be quite interesting. So once the baby is born, there was often a concern that there is maybe some asphyxia, but we might go to delivery, there's a concern from the obstetrician, but the baby comes out screaming, and so we often then don't stay and assess the baby because the baby seems to be fine and the mom gets cuddling. But there's more and more studies out, and I just picked 5, where they're analyzing the infant cry after birth, because it seems to be that when there is asphyxia, the babies have a higher pitch cry compared to a normal baby, and they're using AI to detect this higher pitch cry and then to detect asphyxia. Does it work? Well, I just picked results from 4 studies because I couldn't find the result from the 5th study. They're relatively accurate. It's a bit variable depending on the device, but it's 97% accuracy. It's sensitivity could be a bit better. It's only around 90%. Specificity could be a bit better, but it's just the first step. So maybe in 5 to 10 years, when this technology with the cry and enough data has been accumulated, maybe we will have that, and then they say, oh, look, baby has a higher pitch cry, there's this high likelihood of having a HAE, and then we maybe assess the baby. Let's go to the baby, and I think it was either in Oklahoma or it was in San Diego when I was at the airport, and I found this under the toys in a toy shop. The Waldorf dwarf with amniotic fluid. I was like, I wouldn't buy it, but I certainly want to take a photo. And the bag is the room, yeah? So what did they know what I don't know yet? Is that's the new approach. So maybe it is the new approach, but certainly not something I will experience in my lifetime. Now, as I said before, we moved to trying to resuscitate attached to the cord. The data at the moment doesn't, individual studies doesn't support it yet, but hopefully when we get all the studies together, we get enough data to say, look, this is the way forward. And this is just a few of the tools out in this area. Why is this important? Well, the longer you do, in particular when you try to do the longest deferral, over 120 seconds, ideally with respiratory support, the lower the gestation is, the more likely those babies survive. So it's certainly quite important to optimize cord management. Now, I'm pretty sure all of you have seen at some point studies like this where, and this is from Ellen Blake from CHOP, where they were putting preterm lambs into a plastic bag, run an artificial womb and figure out a way of keeping them alive. And now the question is this going to be the way? And if you type in artificial womb into Google or Bing or whatever you like, these things come up, and they come up quite realistic. Like it looks like someone already does that, and it looks like babies in containers like this where they're just growing. But this is just a fake news article, but you need to dig really deep into these articles to figure out this was just a hypothetical case. But this is something which is done in many centers. There's one in CHOP, there's one in Johns Hopkins. This is from the Michigan University. There's one in a children's hospital, a hospital for sick kids in Canada. So there's many more who try to do this and figure out what is the way. But we're still far away. The original study a decade ago, roughly, they were able to have 8 premature lambs at that early age, were able to keep them for 4 weeks and tried then to take them out. There were still a lot of issues at that time. And I remember I saw a talk from Alan Blake in Canada where he actually already had photos of the prototype of the device, how the babies were growing. Now, that was a decade ago, and I don't think they're any further. Because if you look at all the studies they have done, I think they're still trying to figure out a lot of things. They figured out some ethical frameworks. They're still working on a lot of details to actually keep the baby as long as possible alive. So they're not there yet, so maybe it takes another 10 to 15 years, but given that there's so many other sites trying to do the same, there certainly could be a push to get this to the next step relatively quickly. All right, let's go to monitoring. We heard a lot about monitoring. What is monitoring? What might be important from a monitoring perspective? This is what I learned, and then when I was finished with my training, I was told nothing works, you can't do anything, so we need to look at other things. And that sparked certainly a lot of studies on trying to find normograms, and if you now look for normograms, you find one for blood pressure, for oxygen saturation, for heart rate, for NIRS, for oxygen extraction, for end-tidal CO2. So for everything you will find a normogram because someone made it. So certainly we came a long way, but maybe this is not the step we going, or maybe this is something we go in the next little while and then move on to some other technologies. These are maybe something which is already available, the dry electrode or the NeoBead, which is the same from Leerdal, is FDA approved, so you can easily slap that on, which is relatively quick. Within a few seconds, up to 6 seconds or so, you get a heart rate, and it works really well. Anoop was using that in one of his studies as well. I know that some of the companies and others in the internet, if you can find they use these blankets where the sensors are inbuilt, so you could actually, every baby who is born in the blanket, you get sensors and they can measure heart rate. That's something then comes the question, is every birth need to be monitored that way, or is it only that we need it in some babies because they are sick? Or maybe we get something very simple where, it's green, it's fine, yellow, it's not so good. Maybe you need to do PPV and red, or maybe you should start chest compression. So maybe we get a simpler tool as well. And certainly all of this sparked development also of a lot of different devices. There is all these monitoring devices. We can monitor a lot of things, or just simple, just respiratory function monitors, but certainly a lot of these devices are out there. This biostamp I mentioned earlier on a pregnant person's belly. You can see what it all includes. So maybe you can just stick that on for the first day or two onto your baby, and then you just get all the numbers into your EMR system, and then you can monitor all the babies that way. Julie and myself, we use a different technology, but we don't use it at birth. We use it more for when babies go home. So we use an oxygen saturation monitor for Massimo, which you put on the baby, and then the parents have an app. You have a clinical portal where you can monitor all the babies once they go home. So we're just using it at the moment to see if we can monitor babies with bronchopulmonary dysplasia better once they get discharged. But just imagine this system can easily be used in a rural hospital to monitor babies without anybody there, or because they don't have the resources to do so. In France, there's a hospital which is a standard of care already, that they discharge every baby with this monitor if they were on the NICU. So that started last year. So there's maybe something which, when other people get wind of it, they will say, hey, I want that too. So that's maybe something we see quicker than later. And certainly, parents have used many of these devices for a long period of time. Some work better than others, but certainly Liz Fogler and colleagues have shown that, some of the devices have a better agreement, other devices are really, really bad. And if parents use them, it's certainly not something you would like, because they can cause more stress for the parents. And it's maybe one of the reasons why many years ago we used to use these devices and abandon them because they weren't really accurate. Now, a different approach might be to, and Satyan was alluding at how important it is to have blood flow. Now, if you look at this video, this is just a video recording of a newborn baby sleeping. And when you put an amplifier into the system, you can see the changing skin color. What is that changing skin color? That's your heartbeat, because you change your skin color based on your systole and diastole. We don't see that, but if you use an amplifier program, you can see that. Similar with breathing. You don't see the baby's breathing, and when you amplify it, you can see beautiful breathing. So that would be maybe a way to easily monitor other babies. I've tried that. You can download these programs for free on the internet. I just downloaded it. I looked at the baby. You can see the heart rate is around 160. Respiratory rate is around 50. It's not mentioned well. It's a bit wobbly because I was holding an iPhone, and just holding it, so I'm not 100% steady. But you can see there's a little blip around 160, taller one. This is the heart rate, and around 150, that's the respiratory rate. So it can give you that. In that case, it was retrospectively analyzed, but it can give you relatively quickly. And studies who are out there have shown that they're extremely accurate, like only differences like 0.4 beats. So maybe in the future, when you have your video camera and to record videos, you have that as well as a way of measuring heart rate. Or you integrate it in one of these smart glasses. In the future, maybe you just have these smart glasses and it gives you all the numbers you need. You just look at the baby and you get all the numbers instead of having all the monitors around you. So I might say, hey, heart rate is low, do something. This is your algorithm, this is your trend. This is where you need to be. Maybe you need to focus more, and the AI will tell you in the middle, hey, maybe try this, and it helps you better. So maybe this is something where we go in the future. Now, briefly about teaching, because there will be certainly a lot of changes in teaching. We might not do all the teaching as we have done it in the past, where we just have classrooms, didactic, or maybe just workshops. So maybe we move on and do some virtual reality teaching, where we recreate the environment the patients are in, and then have people where you can see the arms. There were virtual reality classes, and then provide resuscitation training. We can do that as an in-time training, or we do that during a course. It's often found relatively realistic. Still, a lot of people have adverse effects, like they get eye strains or motion sickness. And if this technology moves on, you might just sit in your office and train someone in Australia while you sit in your office in New York, for example, because VR doesn't need to be, you don't need to be physically in place. So there's maybe something where you can teach people around the world the same skill in the same way, because these things are affordable. Often, particularly, there's really cheap, affordable VR glasses as well. So that's maybe something which will come in the next little while, because these programs are available, and even the AAP has created one with Rachel Umorn. Good. Now, briefly about mask ventilation. What might be different in mask ventilation? We heard about mask ventilation. We heard about that it's problematic. We heard about that it's challenging because the glottis might close. When we do mask ventilation with area obstruction, with mask leak, the tidal volume we deliver is quite variable, so we never know how much we're giving. We have tried things like respiratory function monitor. We can reduce the leak. We can reduce the volume we are giving, but it's maybe not always as easy because the mask is often too big. We don't have laryngeal masks yet for these extreme premature babies. Hopefully they are coming, but they might be still a while. So certainly we might need to find other ways. An Australian company said, hey, maybe we just put some suctioning on the side and suction that mask closer to the face, but it didn't work as well as they were hoping, so it didn't really make any difference, in particular when they were trying to get the mask leak that was even higher than with the conventional mask. So maybe that's not the best way. But maybe we can do 3D printing. We can print an individual mask for the patient. How are we going to do this? Well, if we get an antenatal ultrasound, and they're now in 3D and soon even in 4D, you can see the face, which looks quite similar to the ones the baby is born, and then you just print a mask. The mask printing takes half an hour. Yeah. What can you do? The mask can be environmental friendly, it can be degradable, it can use thermal material so that they molds to the face. And you can use not only face mask, you could also use a nasal prong, for example, because nasal prongs might be better. So maybe, and then you can use it on the NICU as well. Because so how often we have this problem that someone says, oh, we can't extubate because we don't have equipment, for example. So maybe then you just start using a 3D printer in the future in your NICU every time you need to go to resuscitation, because you know the size, and then you just printed that, and they will go faster as well in the future. Yeah, and these are one of the latest ultrasounds, so it might be even easier to get these things designed of this imaging. Briefly, I had one slide already about simulation, but I have a few more. I always like this to highlight when Formula One is doing a pit stop. They often train it up to 100 times on the weekend. We train once every few months to do what we do daily. They train up to 100 times on the weekend and still make a lot of mistakes. So it just shows we might have to rethink how we train. I don't think this will change in that we get rid of any of the mannequins, but those mannequins might get advanced. Maybe we use augmented reality where we place certain things on top of the mannequin to help us visualize, for example, how to put in an endotracheal tube, how to place a laryngeal mask, so really help us to get our skills up and running. And there's many different things available. There's virtual NICU available, there's games available, like this one from Drexler, where really you want to just, it's designed that you diagnose and treat a pneumothorax, so you can play around how to treat the pneumothorax correctly. And that's certainly maybe something where in the next little while there's more and more coming out to help you get better with your skills. This is something we have developed where we use digital games and board games to improve knowledge translation. And if you look at what the knowledge was at the before we did the study to the post days immediate after, 2 months and even 5 months later, they were quite able to retain the knowledge better. And other studies by Rachel Umoran, for example, have showed the same thing, that you can really sustain the knowledge for a longer period of time. And there are many other ones. This is a virtual reality game out of Singapore. There is one from Helping Babies Breathe. So there's many more out, and they are used more and more frequently, where they really can say what I have to do, and you can train. And as I said before, you can be wherever you are and just train these people. It works quite well. The side effects, pretty sure will get better over time, so this can be worked on. But that might be something we see in the future as well. And one of the last points, I don't know if this will ever happen, but drones are everywhere nowadays. You might get soon your Amazon delivery via drones. They're used more and more also in medical research. One of the main things is AED delivery. So if you have a heart attack and you're not in in an urban center, you're rural somewhere, the drone will fly, it delivers your AED, and it's up to 7 minutes faster. It might go from one floor to the other, or directly to patient beds to deliver your medicine. I'm not sure if I want that noise all the time, but that's an idea. I think Susan told me that in London they deliver blood work to the lab, central lab between the hospitals via drones instead of driving. So, you know, maybe in neonatology, if you need, you have a level 1 somewhere, a birthing center that needs surfactant, you can just ship it via drone there, and they can give the surfactant, and the baby will improve until the transport team is there. So there's maybe many opportunities, because the radius might be small still with 10-mile radius at the moment, but this will, as the technology goes better and the batteries get better, this will go further and further. So there might be something in the future where we really can use this technology to help more of the rural sites when they are needed any of our equipment. I'm not sure if it's going to happen. I cannot imagine it, but you could actually, instead of using a transport service, you can just use the drone to go from one hospital to the other hospital with the baby in it, and you just monitor it. I don't know if I want that, because what happens if the tube slips? Because then you're in a dilemma, but, you know, who knows, or, you know, maybe you can just pressurize that thing and you get CPAP like in a CPAP hat, you know, like, so, and see, ChatGPT created that for me when I told him what I want. So maybe this is something we will see in the future as well. That's all I had. As I said, many of these things might never come. Yeah, this is just potential ideas, because there's so many things out there which has the potential to come or might never come. So thanks for the attention, and I'm really looking forward to discussion.
Thank you so much, Dr. Schmölzer. What great food for thought. I'd like to invite Drs. Heidi Herrick and Ryan McAdams up to the stage. Dr. Heidi Herrick is an assistant professor in pediatrics at the University of Pennsylvania and an attending neonatologist and clinical investigator at CHOP. She has a master's in clinical epidemiology, and because apparently she takes this lifelong learning things very seriously, she's currently completing another master's in human factors and ergonomics. Dr. Herrick's research focuses on the application of human factors to neonatal resuscitation and intubation to improve provider performance and patient outcomes. She has extensive experience implementing and using video recording during delivery room and NICU resuscitation, and her work is currently funded by an AHRQ Career Development Award. A fun fact, I thought it was super fun that Heidi played varsity soccer at Stanford as an undergrad. But then she told me that on top of that, when she was in her last year at Stanford, she played rugby, and they went to the national finals and won nationals, and all with a broken, separated shoulder. She still played in the game. She's a tough cookie. Welcome, Heidi. Dr. Ryan McAdams is a neonatal intensivist, artist, and AI researcher. As professor of pediatrics at the University of Wisconsin and co-founder of NeoMind AI, Dr. McAdams develops computer vision systems that guide neonatal procedures and detect physiologic patterns invisible to the human eye. Not to be outdone by his fellow discussant overachiever, Dr. Herrick, Dr. McAdams' research spans bench science, translational science, and clinical trials, but all focus on preventing perinatal brain injury and optimizing neurodevelopmental outcomes. Fun fact, Ryan is a former Air Force physician with global health experience across 4 continents, from village clinics in Cambodia to Mongolia's remote hospitals, to assisting in an emergency C-section by generator light in an Ugandan bush hospital. So his commitment to critical care and advancing neuroprotection with a dislocated shoulder. Yeah, there you go. Yeah. Awesome. All right, so welcome. And I guess if we can start, Heidi, questions and comments about George's talk.
Thank you, George, for the talk. Really thought-provoking. So I want to first acknowledge that I'm not anti-technology, but I'm very cautious about it, because I think we don't already use proven technology well, and I think there's a lot of room for improvement with what we already have. So I guess my sort of question to you is sort of twofold. One, how do we start to actually adopt the technology we already know is proven to be better? And also, if we do develop these new technologies, how do we streamline the pipeline so that when we get the evidence, it doesn't take 17 years to actually get it into practice?
Good questions, good questions. Yeah, I totally agree. Like, even if you look just at simple things like respiratory function monitoring, near-infrared spectroscopy, the moment you put that into your delivery room, people start looking at that, but not at the baby anymore. Yes. And you have published that, we have published that, others have published that you then doing PPV look a minute at the screen and never at the baby, and the baby's like screaming and trying to fight whatever you want to do. It certainly is challenging. If these things are done by companies, I think we need to be involved as early as possible to support them, to advise them what we need. But we often overruled, isn't it? Like give us a product and then it's like, try to use it. I think we need a lot of more work in human factors to figure out what will work, what's ergonomic for us. It might be completely different in your hospital than Ryan's and my and Bobbi's hospital, but that's not the point. The point is really to figure it out, what works well in the workflow. And I'm skeptical as well. I don't think a lot of these things that might come or might not come, but we shouldn't jump on all these things. It's not, medicine has never jumped that quick compared to many other areas anyway, just because of the rigid government structures often we can't. So whenever it comes, I think we need to be just cautious and really try also to involve as many people as possible, including the parents, as I said, because they want to have a word. I don't know if because we just were trying to do an AI study with Harvard, Meta, and just when we put AI in our ethics application, it took 18 months to get approved because everybody was scared. It's like, oh, AI. I was like, yeah, we're just doing screenshots of an X-ray. It's not that wild, but so I think there's still a lot of resistance, a lot of scaredness in a lot of people. So I think that will certainly take a while.
Thanks, George. Dr. McAdams.
So, George, we were talking last night, and we were commenting about if we have an idea, someone else probably already has that idea. And so you presented some things I wanted to ask you about, or just bring up as to kind of a segue for this conversation. So we were chuckling as we're showing people throw the babies up in the air and they're rubbing garlic or alcohol or doing tobacco smoke enemas. Like, these things really happened, right? But at the time, people felt like that was good practice, right? So we have this medical orthodoxy or this paradigm blindness. So the things we're doing today, we're like, well, this is the right way to do it. And I think one of the challenges with that thinking is 5 years from now, 10 years from now, what are we doing right now that's going to change? So certainly the way we practice now will change. It's hard for us to conceptualize that. I think the good news is we're doing a lot more science, like the work you're doing, Julie, the things you presented, and there's some humility with that too, because we're recognizing we don't even know which percentage oxygen yet to use. So there is better science that's informing us, but still knowing like the things we're doing now might look foolish down the road. And if I could have an anesthesiologist from Columbia that would be here today, Virginia Apgar, and I said, Virginia, that score you came out with in 1952, we're still using it. And she were to sit in this conference today, and she's like, really, you're still using it? And I'd hand her my smartphone, and she'd probably be like, wow, that's what you're still using to predict things. And so one of my questions for you, George, is this concept of like a neonatal transition score. Could we, with some of this more advanced technology, 5, 10 years from now, with some of these capabilities, and I totally believe in safety and caution, absolutely, but as we gather more data, can we have a score that's less reactive and more predictive? So when this baby comes out with some of the tools where it's very dynamic and it's informing you of what you're gonna need to do in 15 seconds or 20 seconds, and how might this score be used? And it could have a simple like, green, yellow, or red, but it would have much more detail and kind of an ability to help us for that baby right in front of you, what is the best thing to do and who needs what? And I think I envision in the future, will we have a score like that? What might that look like? That's much more dynamic, informed by this evolving data that we're going to get. And I just wanted your thoughts as far as when you're thinking about all your research and heart rate and chest compressions and all that, knowing we're trying to, there's a lot of limitations, but if some of this comes true, like, do you envision, like, in 10 years from now, are we still using an APGAR score as a sole thing? And then, or is that evolved?
Yeah, it's a good question. I mean, there's work from Mario Rüdiger from Germany who created an extended APGAR. Yeah, we don't use it. There's a few publications out which use them. I think it's a lot of work, this extended APGAR, for a lot of sites. That's why they might not use it in detail. Would a new score? Yeah, I mean, I think if you can figure out with AI, whatever technology, that, hey, these 5 values are not that important, particularly if you go down to premature babies, because, we struggle. If you have a baby intubated, do you give them a 2, a 0? Some give a 0 because you bagged. The other one says, no, it's a 2 because it's breathing. Like, oh, okay. Like, even that simple question often is really challenging for a lot of colleagues to answer because they don't know. So I think if you figure out a score with AI, yeah, anything we do with this technology or with AI, I think we can use that to do the next step in the research, because yes, the score is there, then you develop a new one, it just needs to be validated. And you say, look, it is actually better, it's easier, and it helps. Yeah, because Julie also showed that the 5-minute APGAR scores is predictable. So I think whatever we use, as long as we can integrate it in a certain way and validate it, because the fear is often then someone comes up with something new and everybody runs with it without ever validating. And we've done that often in the neonatology in the back. And then people say, hey, hang on, that wasn't the best idea. Let's go back.
Can I just
Please.
add one thing to that? You mentioned sort of validating a few times, and I think I struggle with the word validate in the delivery room, in that we don't know exactly what are the right outcomes, what are the right quality metrics, things like that. So I think I posit to sort of us as a larger community, like, yes, ILCOR did some work early on with trying to develop neonatal Utstein, but we're still not necessarily reporting on those. And so I think that also limits our ability to do any of these validation studies. So I think we also have to decide as a community, what do we care about? And not just us, but what do the parents care about? And also what we care about, not just because, I mean, let's be honest, we're all resuscitation scientists, and at the end of the resuscitation, the baby might still die, but it was still a really good resuscitation. How do we measure that quality? And I think that some of those questions also have to be answered as we try to develop new scores, because it might be predictive of something, but is it the thing that we actually should be predicting?
Yes, and just to top on that, you mentioned the Utstein. Yes, we developed the Utstein. We also developed these outcomes and a survey with the ILCO people, what's critical and what's important outcome. Neither of these 2 parents were involved. So it's the neonatologist thinks that's important. And every time we talk to parents, it's like, that's not important for me. Yeah, what happens at 15 years of age? Or can my kid find friends? That's more important. Now, we can never design studies around that, because if I go to NIH or CHR, our funding, and say, I want to do a study powered for can the kid find friends? Try that for the next 20 years, you will get funded. No, you're totally right.
All right, we'll open it up for some questions. Rena, why don't you go ahead first, and then we'll do Edgardo, and then back to Naomi.
I'm Rena Linder again from UIC. Thank you for a really cool talk. I was like, my jaw was on the floor, half these images, imagining our future. So in my medical educator hat, and question for all 3 of you really, is what is your vision for how AI can be integrated into like a precision medical education, for example? Like, can we take video recordings of resuscitations, look at eye tracking, or how they respond to timing of PPV, or the way they even counsel parents and their tone of voice, or kind of, I guess those are my ideas. Of what are your thoughts on that for MedEd?
I think that in my mind, I think using it as an educational tool and how we teach people to do things, whether it be hand movements during intubation, whether it be responding to parents' tone, things like that. I think that's probably going to be the first place we can start to implement it, because I think, one, it'll feel a lot safer for folks to do it that way, but I also think it's invaluable. You look at some of the literature in surgery education and like looking at hand movements, and they can immediately differentiate between a novice surgeon and a more seasoned surgeon. And so I think that we're doing a lot of our education not well. I think we're trying really hard, but I think there's so many, these tools could augment that so nicely. And I think that one of the things that I struggle with, and you brought this up a little bit before, George, is that medicine is behind in a lot of these technologies. And I think we could catch up in education, because I think that the risks around bringing it into education are less than bringing it into the clinical environment, because I think people just aren't quite as scared about that. So I do think sometimes we're a little bit limited in that, like, ooh, industry can do this, but we can't because of HIPAA. But I think in education, we might be able to do that more. And I think it would be an amazing, amazing tool for that. We've even done just one-on-one debriefing with people after, and I know you do this as well, after resuscitation, and sitting down and watching it with them, and the amount that you can just learn just watching it with them, making them watch it. If you had a tool that could augment that to actually be like, hey, this was an area, like here's like an area of improvement, here's this, just could highlight a few of those things, it could make it more scalable, so it wasn't that sit down next to the person for the whole time. You're still gonna need the human to help with it, but I think it could really, really be cutting edge for education.
Yeah. There's a company in Toronto, and they developed a black box. It's called Black Box, and it's actually cameras in a surgical room, and it records everything. It gives you reports, where the hands were, when you cut, what you cut, how you did this. So, so there's certainly, for analyzing the resuscitation for a teaching perspective, you can say, look, this is what you did perfect. This is okay, we need to work on this, and it might be less judgmental because the machine tells you, not, yeah, Ryan told me I did it wrong, like kind of.
Just to add on that, we've watched a lot of videos the last 2 days. So Anoop, you showed a lot of your videos, and you see helping hands in those videos, but how, by seeing those hands, is it actually helping us? So we focus on a lot of things, but we're not really looking at hands and things like, how are we studying that? And I think it's so long overdue in our field. Like, I think this group gets it, but you think of how we study, like with film, with like sports and high-level sports. You think of the NFL, how much money's on the line, and they study the heck out of these things. I mean, they have teams of people literally studying all the time. They're doing the game after the game. They study individuals, they study team, and we're like so long, and that's for like a game, and there's a lot of money on the line, but like there's a life on the line here, and we're not studying like team dynamics, individual dynamics in a way that we could. So I think that's where, like, especially in simulation, you could leverage a lot of this technology that could do all that and really help you, and it's a much safer space. Like, one of the things I worked with some students on is like, well, why don't we do debriefing in virtual reality? And now with natural language processing and the powers of LLMs, you could have an avatar that looks very real that you need to break bad news to. You need to tell that mom or dad that their baby died, or there was a racist comment made. Now you got to go deal with that and navigate that conversation. And I'd much rather do it and get really good at it in VR and have done all different types of scenarios that you can challenge me with. You know how I performed before, so I have a tendency to do this, and it's gonna help me, right? Because some people are like, oh, they're unteachable. It's like, well, we just need to find a way to teach them and get them to that right point. But I'd much rather have that unteachable person practice 100 times in VR and get really good at it, and I can actually see how they've improved, versus sending them into a room with parents. And then like, oh, that went terrible. That parent was angry before you went in the room, now they're really pissed off. And so I think this is like where we can leverage some of this technology in really safe ways for improvement, right?
And moving the harm from the patient, from the parent, and into, like, to the mannequin, to the VR, do that. Like, really, I think about this from an intubation standpoint too. We talked a lot about just-in-time training. There was a RCT with the anesthesiologist recently that showed that, like, success was much better because with the folks that did just-in-time training that morning. So move your first failed intubation to the mannequin right before you intubate the baby. Like, I think we have so many opportunities, whether it be like low-fidelity mannequins, whether it be virtual reality. I think there's a lot of opportunities here.
Ricardo.
I have comments and questions. So my reaction is, I think I agree with the panel about how much we have to learn from sports and how much example from the sport we are not using. So in this short conversation, we have the F1 and the football team. And what about in baseball? You measure in tennis, they measure the speed of the ball without touching it. And we have so much to measure in the living room to improve. My question, and this is my comment, so I think there's a lot of, we need to pay more attention to sports and team working and video and learning from practice, etc., etc. On the other hand, we have been telling all the time that ventilation is critical. And we are doing a manual ventilation on a thumb that is always different in duration, in frequency, and we have so many automatic things to do. And I think that, Georg, you did a lot of new automatic intention, both to provide ventilation, and there's a new technology to evaluate the second-to-second, minute-to-minute change in compliance, in chest volume. Why we cannot shortly make some adaptation and tailor the ventilation to the patient needs second-to-second? And we are still thinking on providing human factors that are not very good on keeping sustainable inflation as the patient need.
I think for doing this, I think we actually need to start measuring in the delivery room. You know, like, yes, we measure with a flow sensor, but we need, like, I can remember many years ago when I went to Alberta and I wanted that the ERTs use a respiratory function monitor in the delivery room. They're like, no, I know what I do. I was like, I don't think so, but that's okay. So I went to the unit and put like garbage bags on all the ventilators, yeah? And I said, hey, we need that. They said, no, you don't, because you don't need it at birth, so you can't need it on the unit. What's the difference 20 minutes later? So I think there's still also this mindset everybody knows what they do at birth. We don't need to measure anything. And I think we really need to start measuring every value, because if I want to adapt whatever that baby needs, because every baby will be different. It could be, premature rupture of membrane, choreo, and then maybe the machine learning can help us to say, look, if you have this baby, this is what you need to do, and then you need to study it. And no, we can't just say, oh yeah, that will be right. So then we have to study it and see if it's true. So we can do it, but it's a long path.
I also think that I totally agree. We need to be measuring things. I think we need to be measuring it without showing people data, because we don't know what to do with it in the delivery room. Like,
Yes.
we talked a little bit about that. I think that there are a lot of unobtrusive ways for us to get more data to start then figuring out what these babies need. Because I think that we could have the technology to deliver some of this, but I don't think we know what they need yet.
No, we don't.
I think EIT, needs to be in there to start looking at this. I think we need to start getting more of this data. But again, I think the problem is we get so excited about it that we're like, oh, we can do this. We should do this. Now let's change how we do it. When, like, again, going back to it, we don't do basic NRP particularly well. Like, the amount of errors, the amount of deviations from it, I think we, again, and we don't know exactly the right thing to do. So I think data, figure out the right thing to do, then study it rigorously. Yeah.
One of the things I was
Hypothesize.
thinking about along those lines of gathering information, I think, Anoop, when you were talking today, maybe it was you, about CO2 monitor, and you'd like to know more information. And I think right now it's did it turn yellow or not, right? So we're saying, okay, that we're ventilating, but why not have it be like maybe 3 different colors, and you'd know, like, well, if it's this color, it's less than 40. If this 40 to 60, if it's this, it's greater. So, like, it doesn't have to maybe get to the point where it's telling you exactly what it is, because maybe that's too costly, but more information that we need to start kind of gathering, recording, and then understanding it. So this whole pipeline must, I think, to start with, it needs just more data, good data, and then trying to analyze it and then go forward with that.
Yeah.
And I also think what Anoop needs might not be what I need in the delivery room too. Like, I think we talk a lot about the baby being the variable in there. There's a lot of other variables that are in there too. And I think that, and I think as we talk about this new technology, it's amazing. I also think we need to think really, really hard about how each person individually is going to interpret it, and also who's going to have access to this new technology too. I think that's the other thing that I really worry about, is whether or not these new technologies are just going to increase disparities and making sure that we're doing it in a way that is not just increasing that.
Yeah, I mean, and I think getting more data, maybe deep learning can really help us with video cameras, because even if you run a simple trial, people do not write down things. Is it like a delivery record? It's like sometimes 5 minutes are missing. It's like, what happened? Oh, we were so busy. Yeah, so we need a good system of how we record data as well, because it's not happening in every delivery because it's too expensive, because you'd be able maybe to get a good recording system for your high-risk delivery, but then you have 20 other rooms and you can't afford anything there because it's just too expensive. So we need a good system to start recording, and so that we then can actually do the next things.
I know we have some online questions, but we'll do Naomi and then a couple of online questions, please.
This is a really thought-provoking way to end the day, and I think your talk was intentionally provocative, and I find myself provoked. And I'm thinking about something I learned recently, which is that in the last 12-ish years, the number of global internet users has gone from like 2 to 5 billion. And my first reaction to this was like, that is 3 billion more TikTok users. Why could that possibly be a good thing? And I stepped back and thought about like what actually comes if you live in a low and middle income country and you have access to the internet. But that's not what the internet was invented for. And when you show these sort of interesting ideas that are coming, and I think about those ideas coming out of investors, and I think about the ways that like I use AI as a time hack, right, as a time-saving device. It makes me more efficient. And we can think about AI that makes us better. It takes our level of performance up a couple of notches. But where I get really excited and find myself provoked is the way that AI could equalize, right? It can get that AED to someone that the ambulance can't get to them. It can bring technology to places that can't get it. And do you think there's potential to get it right this time, where that's not a remote side effect of things that we did to make money, but that those goals of using this technology to equalize are at the front instead of at the back?
I think that's totally possible. It has to be prioritized, though, and I think the companies like OpenAI, I don't think they're highly concerned with like the person in the village about to deliver in Uganda. They would say they were, but like they're not. They want to get to AGI, and there's a lot, there's billions of dollars pushing them towards that. I think with the phones that we all have, the cool thing is phones are very advanced. They have a lot of capability in them. So if let's say you're in Rwanda and you're in a village, and Rwanda's the land of 1,000 hills. It's got really tough terrain. So let's say you're there and you're about, there's a birth attendant and there's a woman, she's laboring, and you could use your phone for things. The phone could look at her conjunctiva and tell if she's anemic or not. You could take a photo of her and figure out, based on her fundus height, how pregnant she might be. You could put the phone on her, and with seismography, it could detect kind of like how often she's contracting. Using ultra wideband sonar, or radar, which the phone has, you could likely figure out fetal heart rate. So then in Muhanga, Rwanda, which was established in 2016, Zipline has a drone station. So then you could contact them and say, here's the information on this mom. Oh, by the way, she has a fever as well, because your phone could have an infrared thermal camera. So like, okay, what are we gonna send? Right now it can send 8 pounds worth of material. So you could have a kit that's just gonna go. So it's gonna have CPAP, LMA, surfactant. It could have a cord clamp. It could have a thermal blanket. It could have antibiotics, and it could have maybe oxytocin antibiotics for mom. And that sends, and that gets there in a half hour. That's a 10-hour walk for someone, just one way, because of all the hills and the terrain. If you're on a boat or a motorbike, it's an hour. But you could have this where then that gets to the site. You could even have an oxygen canister in there that could have 15 minutes of 100% oxygen. So you're gonna do delayed cord clamping, put the baby on mom, and you're gonna do the doxy trial right there. And so there's ways that this could be done in these settings with tech. All you need is a phone. And that's a good starting point. Now, you still need to validate in all this and making sure it's safe, but I worry a lot of this could really widen gaps as well. And historically, it would tell you, we haven't done a great job of this, right? It's like colonialism all over again. And so like, how do we do a better job of like prioritizing that? And that's where I think like groups like this need to focus on like, where's most deliveries? Low and middle income countries, right? Where's most death? Low and middle income countries. So like, if we're always thinking of like, some of this really nuances, like it's sampling at 100, the heart rate, I'm getting 100 samples per second. I really want 200. It's like, do you really need that? Because guess how many kids, 6,400 babies just died today. So I think we have to figure out with this tech, Naomi, absolutely how to prioritize it. And I think that's where I do worry that we could widen the gap And it's like, well, oh yeah, that was an afterthought. So I think the tech could actually solve a lot of the problems. And because of like, cost with economics, think of what a pulse oximeter used to cost. It was like $500. A glucometer used to be a couple $100. Now it's like $10. So it's like, if you scale this stuff, a lot of these things actually get to a price point that makes it feasible that we could do some of this. So I think the possibility will be there. It's just, will we do it or not, that's the question.
I'm so sorry to say we're running out of time. We have like a minute left. So maybe we'll just do one of the online questions.
Sorry, Charles.
Yeah, I'm so sorry. But we could talk about that. And we will be talking about this for a long time, but.
Just one question from online in regards to a piece of technology that was not discussed yet. What is your assessment of the effectiveness of thoracic impedance monitoring for evaluating neonatal ventilation?
Thoracic impedance, like EIT? Well, it has been used I think it's been used in several sheep studies. Like there's a lot of sheep studies that it has been used to show how the lung is aerating, which was the next step after all the rabbit pup studies where they were hanging and people were complaining, well, that's not real because they were hanging instead of lying. And the EIT study showed the same, but there's only 20 babies in that study. So it is being used. And I think it was the base for doing the polo trial because all the sheep work David Tingay did showed that, oh, look, if you aerate the lung in that way, it might be the best way. Would I use it on every baby? No, not right now. There's many systems out there. There's different systems than EIT as well. One is called Angelique from SLE, which can be used. So there's systems out, but I think it's not something I would use routinely. It might help you in certain cases to see how the lung is aerated, but that still hasn't been tested well enough yet in my mind.
I think it also might help in the unit a lot too with some of our more like chronic babies, or like I think that at least the cases that I've seen too are like the baby that develops a pneumo, that the EIT could help you in that moment. You're not transluminating, maybe it works, maybe it doesn't work. You're not waiting for an x-ray. There are ways, I think certain high-risk babies in the NICU might be a nice way to augment that. I think right now, again, because we don't have enough evidence for it, but it also is another thing you have to pay attention in the delivery room. I would hesitate to put it there yet. I think sometimes there's a fair number of things that we could implement in our NICU in sort of a less high stakes, still very sick patients, but a less high stakes environment where you have a huge cognitive load, see how we use it there, and then see how we can adapt it for the delivery room.
And on that note, I think we're going to have to stop. But thank you so much, Dr. Schmölzer, Herrick, and McAdams, for a fantastic conversation. We really appreciate it. So it is... If I could just have the last two slides, please, up, I'd appreciate it. Thank you. So it is my pleasure to just say to all of you who attended, thank you so much for your participation, your active involvement, your excitement. Certainly thank you to all of our speakers and discussants who gave us so much to take away today and yesterday at the workshop, and the colloquium. So it was just a fantastic couple of days. Thank you. The planning committee is the most phenomenal group of people to work with, and so thank you very much to the planning committee, but in particular, Edgardo Shield, although he drives us all crazy a little bit with his enthusiasm sometimes, is so effective and gets so much done. So thank you so much, Edgardo. You're incredible. Our educational partners, including Mead Johnson, Fisher & Paykel, Medtronic, GE Healthcare, Chiesi, the AAP, and RQI, make this possible. They make it possible for us to interact together and bring people in from around the world so that we can all do better for babies. So thank you to our educational partners. We're really proud to partner with you. And in particular, Fisher & Paykel brought us some equipment yesterday for the workshop, and I was very remiss at the end of the workshop. I think my brain was a little bit fried. So Fisher & Paykel, thank you yesterday for all the equipment that you brought us for the workshop, so thank you. And then this is really, truly the last thing. Marilyn Escobedo has mentored so many of us in this room and around the world for so long. And it makes me very sad that she will not be mentoring me in this capacity anymore. However, I could not be happier for you and your amazing life and your husband and these grandkids and all the things, and maybe walking on the beach. And Marilyn, you have influenced so many of us so much for so long. You are so deserving of a happy retirement. Thank you from the bottom of my heart. Okay, and then finally, just save the date for next year. We want to see everybody back again next year and maybe some more, so bring a friend next time. Thank you, have a great weekend. Enjoy the lovely Indianapolis weather, because of course this is how it is for us all the time, but maybe you don't get that at your house. So thank you so much. Have a good day.